again. Welcome back, dear students. This side Govind, your chemistry faculty. We have completed. Very soon, we are going to complete D and F block element, and D block element is almost completed. Video will be uploaded soon to the channel. You can go through it once and check it. Ask your doubt. And today I am going to record video for the F block element. Okay. So this time it's time to record video for F block element, and I will try to complete this F block element in one lecture only. Okay. So just going to record. Be with me and check it. So here we are having F block element. These are also called inner transition elements because last electron enters in n-2 f orbital. In the periodic table, two series below the periodic table, lanthanides and actinides are given. First series is called lanthanoids, and second series is called actinides. Total 14 elements here, 14 here, 28 elements are present in that series. Okay. So in that same case, if you will see the inner transition element. So inner transition element, F block element, why they are called inner transition element, that I told you, because last electron enters in n-2 subcell. That is why they are called inner transition element. So two series are there, lanthanoids and actinoids. Lanthanoids, cesium to lutetium, thorium to lawrencium. These are the series, first series, and this is second series below the periodic table. After this, the lanthanoids elements are present here. General electronic configuration, if you are talking, then xenon 4f 1 to 14, 5s2, 5p6, 5d 0 or 1, and 6s2. This is the general GEC, general electronic configuration of lanthanoids. Electronic configuration. Atoms of these elements have electronic configuration with 6s2 common but variable occupancy of 4f level. The electronic configuration of all tripositive means +3 ions are of the form 4fn, means n means 1 to 14. Second, atomic and ionic size. So check it, children. It's a very simple same time. The overall decreases in atomic and ionic radii from lanthanum to lutetium. The lanthanoid construction, because of lanthanoid construction, is a unique feature in the chemistry of lanthanoids. Second point, however, the shielding of 4f electron by another is less than d electron by another with the increase in nuclear charge along the series. There is fairly regular decrease in the size with increasing atomic number, that is the regular trend. The cumulative effect of construction of the lanthanoid series known as lanthanoid construction. So it's a kind of theoretical chapter, that's why a little bit boring also. Electronic configuration, guys, electronic configuration and radii of lanthanum and lanthanoid. So here cerium. So check it once, children. Here cerium 4, what is cerium? 4f1, 5d1, 6s2. At the +2, 4f2 +2 state, +3, 4f1, and 1 to 14 last. Remaining are given. First element cerium, then praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, terbium, lutetium. These are the elements. So that table is given in NCERT also. You can go through it once and check it, but never ask the electronic configuration, so no need to worry. Oxidation state. So the typical oxidation state of lanthanoid is plus 3 children. The oxidation state of plus 2 and plus 4 are exhibited by some of the element. The irregularities arises mainly from extra stability of empty, half-filled or full-filled F. That irregularity arises mainly from extra stability of empty, half-filled or full-filled F subcell. The electronic configuration of EU plus 2 is half-filled, YB plus 2 full-filled, CE plus 4 empty, TB plus 4 half-filled. In each case tends to revert the more stable oxidation state of plus 3 by loss or gain of an electron. So EU plus 2 and YB plus 2 ions are solutions. Ions in solutions are good reducing agent, and CE plus 4, TB plus 4 ions solution are good oxidizing agent. So cesium, TB, ND, DY, PR also show plus 4 oxidation state. SM, EU, TM and YB also show plus 2 oxidation state. So this is about the oxidation. General characteristic, if we are talking, so all the lanthanides are silvery white, soft metal and tarnish rapidly in air. The hardness increases with increasing atomic number. If atomic number increases, then hardness also increases. Many trivalent lanthanides ions are colored both in solid state and in aqueous solution. Color of these ions may be attributed to the presence of F electron. Neither La plus 3 nor Lu plus 3 ions show any color, but rest of the element do. However, absorption bands are narrow, probably because of the excitation within F level. The lanthanides ion other than F0 type of F14 type all are paramagnetic. If electronic configuration is F0 and F14, they both are diamagnetic, remaining are paramagnetic. The paramagnetism rises to maximum in neodymium. Neo, neodymium. Chemical property with halogens, chlorine, fluorine, bromine, iodine, LnX3, acid HCl or H2SO4, hydrogen liberated, burning with oxygen and oxide, treated with sulfur, then sulfide, nitrogen, nitride, with carbon, LnC2, Ln3C, Ln2C3, this type of carbide will be formed. Use of lanthanoids, if we are talking, so the best use of lanthanoid is for the production of alloy, steels or plates and pipes. The well-known alloy is Miss metal. One time this question came, which consists of a lanthanoid metal 95% and iron 5% and traces of carbon, sulfur, calcium and aluminium. Mixed oxide of lanthanoids are employed as catalyst in petroleum cracking. Some individual Ln oxide are used as phosphorus in television screens and similar fluoro flourishing surface. So these are the things. Now come to the actinoids. Next topic is actinoids. The actinoids include the 14 elements from thorium to lawrencium. The actinoids are radioactive elements. The actinoids are The actinides are radioactive elements, children. All the actinides have electronic configuration of 7s2 and variable occupancy of 4f and 6d subcell. The irregularities in the electronic configuration of the actinides, like those in the lanthanides, are related to the stability of F0, F7 and F14 occupation of the 4f orbital. So here If we are talking in that case, so lanthanide, in the mixed metal children generally main component is cerium and iron. Once again I am here mixed metal cerium and iron. Okay, so the element which the extra electrons, the man-made 11 elements here, NP93 to LR103. These elements are called transuranic or man-made element. Only thorium, protactinium and uranium are the natural element. Thorium, Pa, protactinium and uranium. These are the only natural element. Remaining are man-made. Electronic configuration you can check of the actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, perminium, mendelevium, nibelium, lawrencium. Some names are on the basis of scientists also. Okay. Ionic size, there is a gradual decrease in the size of atom or M plus 3 ion across the series. This is called actinide construction. The construction is greater from element to element in this series, resulting poor shielding by 4f electron. Oxidation state. Actinides have a large number of oxidation state because of very small energy gap between these cells, 4, 5f, 6d and 7s. The actinides show in general plus 3 oxidation state, general oxidation state plus 3. The element in the first half of the series frequently exhibit higher oxidation states. The maximum oxidation state first increase up to the middle and then decreases just like D block element. So here actinium plus 3, thorium plus 4, here plus 3, 4, 5, 3, 4, 5, 6. So maximum is 7 and then decreases plus 3. So plus 3 is the common oxidation state. General characteristic, the actinides metals are silvery in appearance. The actinides are highly reactive metal, especially when finely divided. Hydrochloric acid attack all the metals, but most are slightly affected by nitric acid, owing to the formation of protective oxide layer. The variation in the magnetic susceptibility of the actinides with the number of unpaired pipe of electron is parallel to the corresponding result of the lanthanoids. Basically, you can say actinides are paramagnetic. They are paramagnetic due to presence of unpaired electrons. Similarities between lanthanoids and actinoids, both show plus 3 common oxidation state. Both are electropositive and very reactive. Actinide exhibit actinide construction like lanthanide construction. So by the lanthanides. Difference between lanthanides and actinides, the magnetic property of the actinides are more complex than those of lanthanides. The ionization enthalpy of early actinides are lower than the early lanthanoids. Most of the lanthanides ions are colorless whereas actinide ions are colored because of unpaired electron. Application of D and F block element. Many of the metals or their compound are essential catalysts in the chemical industry, used in varieties of steel, catalyst, complex, organic synthesis, etc. Okay. Catalyst in chemical industry. What are the catalysts used in the chemical industry? That V2O5 catalyze the oxidation of SO2 to SO3 in the manufacturing of sulfuric acid. This catalyzed Ziegler-Natta catalyst is used in the manufacturing of polythene. Fe plus MOR Fe plus MOR used as a catalyst in the manufacturing of ammonia by Haber process. Molybdenum. Okay. PDCl2 is used as a catalyst in Becker process for the oxidation of ethene to ethanol. Nickel complex are useful for the polymerization of alkenes and other organic compounds such as benzene. The photographic industry relies on the special light sensitive properties of AGBR. So these are the industrial catalytic uses, and this way chapter is completed. Okay, so thank you children for watching. D and F block is completed now. So D and F block completed. Next chapter very soon will start. So wish you all the best and thank you so much. So please like the video, share the video as usual. All the best children.